The planet Venus is the brightest object in the sky after the sun and moon. Records dating back to the Babylonian civilization reference Venus as a bright celestial object in the skies. Other civilizations, such as the Egyptian, Greek, and Chinese, include observations and cultural lore about Venus. Interestingly, historical references sometimes called Venus the morning star or sometimes the evening star. The ancient Greeks called Venus by two names, Phosphorus and Hesperus, supposing it to be two completely different objects. The two-object idea isn't completely unreasonable, since for a portion of our year, Venus precedes the sun in the sky, so it will appear in the early morning just before sunrise. For the other portion of the year, it follows the sun, being one of the first objects visible in the evening. In fact, Venus is never more than 48 degrees from the sun, which is termed its greatest elongation. This alignment is due to its orbit being inside of Earth's orbit, closer to the sun. And in fact, 2 Peter 1 verse 19 makes reference to the day star that would rise when the day is dawning. In this verse, the words day star are translated from the Greek word phosphorus, which is a reference to the planet Venus. In more modern times, Venus has taken on the description of Earth's twin, or maybe Earth's sister planet. Venus is not only the planet that travels closest to Earth in its orbit, but it has such nicknames because it's nearly identical to the Earth in its size and its mass. However, Venus is an interesting case study in planetary characteristics, since in actuality it is extremely different from Earth in almost every other way. From a distance, we first notice that Venus is enshrouded in a thick atmosphere of clouds. This atmosphere is far thicker than Earth's. It's mostly composed of carbon dioxide and has an atmospheric surface pressure 90 times greater than Earth's. In fact, to experience an equal amount of pressure here on Earth, you would have to travel nearly 2/3 of a mile below the surface of the ocean. Such a depth is beyond free diving or deep diving without specialized suits or specialized vehicles to handle the immense amounts of pressure. Additionally, because of Venus's extremely dense atmosphere, we cannot see its surface without the aid of special imaging such as radar. In 1990, the Magellan spacecraft was sent into an orbit around Venus, and it began taking images using its radar altimeter. This allowed scientists for the first time on Earth to map the varied terrain of Venus's surface. In October of 1994, NASA lost contact with the Magellan satellite. But over the course of these 4 years, it was able to image 98% of the planet's surface. Beneath the thick clouds, Venus's surface shows signs of volcanic activity, possibly even presently active. In fact, a 5-mile-high shield volcano named Mont Mons has been revealed by the surface radar mappings. And although it's unclear if Mont Mons is still an active volcano, there are lava flows that can be seen extending across the plains to the base of the volcano. With Venus's thick carbon dioxide atmosphere and having a solar irradiance twice as high as Earth, Venus has the hottest average surface temperature in the entire solar system, over 860 degrees Fahrenheit. The extremely thick atmosphere also traps the heat in a greenhouse effect, so the temperature is pretty much always 860 degrees, whether it's daytime or nighttime. Such an incredible temperature means that liquid cannot be present on its surface. This is a stark contrast to Earth, where more than 70% of the surface is covered with water. Not only could liquid water not exist on the surface of Venus, but even metals such as lead and zinc would liquefy if they existed on Venus's surface. Another significant contrast between the two planets, Venus and Earth, is the presence of Earth's strong magnetic field. The rather fast rotation of Earth, once every 24 hours, is thought to maintain a steady and sufficiently strong magnetic field to provide a finely tuned cocoon from the dangerous streams of charged particles flowing from the sun. By contrast, Venus has an extremely slow rotation, once every 117 Earth days, and Venus lacks any magnetic field that could associate with protection from this dramatic solar wind. Although a few forms of life on Earth were designed to live in extreme environments, the entire planet of Venus would qualify as an extreme environment. The atmosphere of Venus is 90 times more massive than Earth's and maintains a world of very little variation and no seasonal changes. It also holds the record for the highest average temperature of any planet in the solar system. So without oxygen or water, having an extreme atmosphere, extreme heat, and no magnetic field to protect from dangerous radiation, Venus could not sustain life. While Earth was designed by God to bear a host of thriving ecosystems, He did not design Venus to be Earth's twin.